Hello friends, very good morning. Myself Dr. M.H. Chennaiya. In this video, we are going to work out a numerical problem on a screw jack or a power screw. Let's see what is the question we have for today's video. The question reads as a machine weighing 20 kilonewton is to be raised by a single square thread of given dimension, and we have been asked to determine determine the power required to lift the machine, and this is what is required. So you know very well in all this machine design subject, there is a relation connecting the power transmitted, the torque and the speed of rotation, and that is being given by torque mt is equal to 9550 into capital N by small n. This will be in terms of Newton meter into 10 to the power of 3. This is given in MDH. If you refer to any machine design data handbook, you will have this relation. This is nothing but P is equal to 2 pi N T by 4500. That's all converted and reduced to this form. And this formula can be utilized by any student or readers to solve a problem on a gear, a shaft, a key, or a coupling, whatever it may be. This can be remembered and is also available in the machine design data handbook. And what that's asked here, so we have been asked to find out what is the power. This N stands for the power transmitted in kilowatts, in kW, kilowatts. And friends, to find out this, we need to know what is the torque transmitted and what is the speed of rotation. If you are able to calculate these two parameters, then you can substitute here and obtain what is the power required. That's what the question is. So friends, first of all, you have to calculate what is the torque MT required. Friends, you know very well, for the screw jack or the what is called screw jack or power screw, we have the formula. I can write down here for screw jack. We have the formula. The torque MT is given by the formula for the screw jack, that is W d2 by 2 multiplied by 1 plus tan alpha. So 1 plus mu tan alpha plus divided by tan alpha. So it is W d2 by 2 tan alpha plus mu tan alpha plus mu it is plus mu divided by 1 minus mu tan alpha plus mu c dc by 2. I will explain each and every term of. Friends, this equation is available in any of the machine design data handbook. So let's see what are these, friends. This W is the load to be raised or load to be lifted. And you see the value is given to us as 20 kilonewtons. I'll say here 20 kN. That's nothing but 20 into 10 to the power of 3 Newton. This conversion is very important. And friends, we have this D2. D2, friends, is the mean diameter of thread. Mean diameter of thread. So you can find out the mean diameter of the thread when you know the outside diameter and the core diameter. So, and this is given by the formula D plus D1 by 2, where D is the outside diameter of the screw thread, D1 is the inside dia or the core dia by 2 to take the average value. And the question is being given as a square thread of diameter 30 mm and pitch is equal to 5. Friends, for the power screw, we make use of square thread of normal series, and it will have a profile like this, like it will be. So here the outside diameter is D, the core diameter is D1, and this is pitch by 2. Again, this is pitch by 2. So if you add D1, P by 2 and P by 2, you get D. That is, outside diameter D is inside dia plus pitch. In the question, we are given with 30 mm dia. So 30 is equal to D1 plus pitch is 5 mm. And hence friends, you get D1 is equal to the core dia, which is 25 mm. So once if you substitute these values, you will be able to get what is the mean diameter. Friends, hence this D2 will be equal to 30 plus 25 by 2. That is 55 by 2 is 27.5 mm. That is the mean diameter of this thread. Friends, tan alpha. If you refer to the handbook, you have this tan alpha is equal to lead means L by 10 by pi d2. This is available in the machine design data handbook. What is this lead? Friends, in a screw and nut arrangement, lead is the distance traveled by either the screw or the nut when one of them is held stationary. That is, if you give one rotation to the nut, keeping the screw rod stationary, the distance traveled by the nut along the axis is called the lead. And here, this lead is equal to pitch for a single start thread, lead is equal to twice pitch for a double start thread, and so on. And in general, we can say lead is equal to N into P, where N will give you number of starts. So friends, here it is said in the problem, it is a single start thread. So here lead is equal to pitch, which is equal to 5. Therefore, this tan alpha will become equal to 5 divided by 5 into 27.5. And friends, this works out to find non-double 0.055 and 36. This is the value of tan alpha. So we have put the value, W is known, D2 have calculated, tan alpha we know, and then mu. Friends, mu is the coefficient of friction, and this value is given to be 0.2 for the threads. So we know the value, 0.2 here. Then mu c value is also given as 0.1. So this is also given to us. And friends, with this, we will be able to determine what is the torque to be transmitted by the coupling, by the screw rod. So friends, if you simplify this, after substitution, mt becomes equal to, this mt is equal to 163780, 163780 Newton millimeter. Newton. This is the value of torque we get. And friends, you have this value, and here the inside diameter, and this is to calculate that DC. DC is given by diameter of the collar outside dia of collar plus DC inside dia of collar, that is by 2. The outside diameter is 60, inside is 30, divided by 2, that will become 45 mm. So this we are going to use while calculating this MT. If this is not specified, we will generally take the value as 1.5 times the outside diameter of the thread. Friends, we have got this value. Now what we do? We can have the substitution made in the first formula. to obtain what is the power required. Therefore, I will say this MT is equal to 9550 into capital N, which is to be found out, into 10 to the power of 3 divided by small n. Hence here this is 9550 into capital N, the unknown, into 10 to the power of 3, and this we want the speed which are not calculated yet. So the load is to be raised at a maximum speed of 6 meters, that you have to calculate to get the answer. So friends, I will write a simple sketch and show you how to obtain the speed at which this nut has to move. So friends, I will just write down here a simple sketch. Friends, see, you have got a threaded rod here. It is a screw rod having the threads cut on it, that is a square thread. And say you have got a nut, this is a nut, and this vertical rod is a rod or a screw rod. So it has to move at a speed of maximum 6 meter per minute. So it has to cover 6 meter from here to here, and we have to find out what is the speed at which it has to rotate, so that by substituting in the formula we will be able to determine what is called the power required. Let's remember here lead is equal to pitch, because that is specified in the problem. The threads are single start, so that is equal to 5 millimeter, that I have shown here. So what's the meaning of this? That is, holding this screw rod stationary, if you give one rotation to the nut, that will fall, that is move down or move up by a distance of how much? 5 millimeter. So if it has to cover 6 meters or 600 meters, I will say here lead is equal to pitch is equal to 5 millimeter. That is to say, to cover 5 millimeter, we need to give one rotation to nut, one rotation to nut. Similarly, to cover 6 meter, that is 6000 mm, we give 600, 6000, 6 meter is 6000 millimeter divided by 5, that is equal to 5 12s are 0 0 12 0 0, yeah, so many revolutions. In other words, by giving this nut 1200 revolutions at a higher rate, it is going to cover 6 meters, and this 6 meters is to be covered in 1 minute. So 1200 meter in 1 minute is nothing but 1200, that is RPM, that is speed of rotation is 1000. If it is moving at a speed of 1200 RPM, it will be able to cover 6 meter distance. And hence friends, using this value, we will substitute in the formula and find out what is the power requirement to lift this load. Therefore, from this formula, MT is equal to 9550 into capital N divided by small n into 10 to the power of 3. If you put the values, 163780 is a value of torque, that is equal to 9550 is a constant in the formula, into n is to be found out, multiplied by 10 to the power of 3 divided by small n is the speed of rotation or RPM, that we have worked out as 1200. Friends, if we simplify, we will get the value of n, that is the power required to lift this load at a speed of so much as 1000, it is 12.862. It is 12.862. Again, 12.862 kilowatts is the power required to lift this load at a speed of 6 meters per minute. Friends, I hope that the presentation was interesting. Please go through the complete video, and if you like this video, please share this information of the video with all your friends without fail. And also, friends, many of the channel viewers have not subscribed to my channel so far, and I request all such channel viewers to subscribe to my channel. And I thank you very much for watching my YouTube video. Have a blessed day.